Hello friends, welcome to our channel DC Math. Today in this video I shall try to solve two differential equations. If the videos of my channel is helpful to you, please subscribe my channel and like the videos and share the videos with your friends. Any equation of the form dy by dx plus py is equal to q is called a linear differential equation in y if y is the dependent variable, x is the independent variable, and p and q both are functions of x only. That is, p and q both are the functions of the independent variable. Then the integrating factor of this equation is e to the power integration p dx, and ultimately we get the solution or primitive as y into e to the power integration p dx is equal to integration over q e to the power integration p dx whole dx plus c being an arbitrary constant of integration. Let us consider this differential equation dy by dx is equal to sin x minus sin y into cos x divided by cos y. Multiplying both sides by cos y we get, let us put sin y is equal to z. Differentiating both sides of this equation with respect to x we get cos y dy by dx is equal to dz by dx. Using these two equations in this equation we can put dz by dx in the place of cos y dy dx, z in the place of sin y, and ultimately get this equation. This is ultimately giving this equation dz by dx plus z cos x is equal to sin x cos x. This is a linear differential equation in z. If we compare this equation with the standard linear differential equation in z, that is dz by dx plus pz is equal to q, where p and q both are functions of x only, then we get p is equal to cos x and q is equal to sin x cos x. Therefore the integrating factor is e to the power integration p dx, which is ultimately giving e to the power sin x. Multiplying both sides of this equation with this integrating factor we get, from this equation we are getting we can write d by dx of e to the power sin x in the place of cos x e to the power sin x. Therefore we are getting d by dx of z e to the power sin x is equal to sin x cos x e to the power sin x, which is giving d of e to the power sin x is equal to sin x cos x e to the power sin x dx. Integrating both sides of this equation we get z e to the power sin x is equal to integration over e to the power sin x into sin x cos x dx plus c. c being an arbitrary constant of integration. To solve this integration, we will use the method of integration by parts. Sin x integration over e to the power sin x cos x dx minus integration over d by dx of sin x into integration over e to the power sin x cos x dx whole dx plus c, which is ultimately giving sin x integration over e to the power sin x d of sin x. In the place of cos x dx, we can write d of sin x minus in d by dx of sin x is equal to cos x. In the place of e to the powers, in the place of cos x dx, we can write d of sin x whole dx plus c, which is ultimately giving here e to the power sin x minus integration over cos x e to the power sin x dx plus c, which is ultimately giving sin x e to the power sin x minus e to the power sin x plus c. Z e to the power sin x is equal to this one. Multiplying both sides of this equation by e to the power minus sin x, we get z is equal to sin x minus 1 plus c e to the power minus sin x. Putting the value of z, we get sin y is equal to sin x minus 1 plus c to the power minus sin x. This is the required primitive of the given differential equation. No more discussion in this video. Thanks for watching. Hope for you a happy study time. Thanks.